Hello everyone, welcome to Layman's AI. Today is a tutorial video on how to use Gen AI models for data classification. Data classification is a common use case where you have to deal with a large corpus of text data and you want to categorize the data into distinct categories which are not known upfront. So, for example, if you're dealing with any kind of log data, which is coming from a diverse set of IT systems, or you're getting product reviews from any platform, right? Any area where there's a large text data and you want to kind of categorize them into multiple buckets, but you don't know the categories upfront. So how do you use a Gen AI model to do this categorization so that you know the broad categories, and then you can individually tag an individual document or a text or a paragraph into one of those categories. This is a hands-on lab, so we're going to see the code as well and try to understand how this is done. All the code is in the link. The link to the code is in the description, so you can see that. So let's begin. So the code is on GitHub. Uh, for this study, what I've taken is a use case where we have a lot of IT log data. These log data are coming from multiple source systems, multiple applications, and the idea is to understand what are the broad categorization of these logs that could be done, so that we have a dictionary of the categories, and then we can use this dictionary in future processing to understand when a given log comes, we can automatically classify into a category. So this applies to any scenario where you have a lot of text data, you don't know what are the broad categories they fit into. You want to find those categories first and then use those categories for all your processing. So this is the log data, a sample log of 10,000 records. Now these are not real data, these are masked data. The numbers and the IP address, they are not correct, but the idea is true. So what we are dealing with is log data, and we want to find out the broad categorization. I have a notebook with me, and I'm going to walk you through the process of dealing with it. Now, what are the challenges that we have in this process of categorization? See, when you have a large corpus of data and we want to use LLMs to do this classification, you can't fit the entire data into the context of an LLM and get the categories. If it was possible, you could fit all of them into an LLM and get the broad categorization that could fit into it. But many times you don't have that, and many times your data is too large and you may not be able to fit that, right? So what you do is fundamentally it's a map reduce approach. What we'll do is, while the entire data cannot fit, the entire data may be too large to fit into your context, but you know what is the context size of the target model that you're using. So you can use that size to break your input document or input source of documents that you have into smaller sets, which are chunks here, so that each individual chunk can fit into the LLM. Okay, so um, if you know that your target LLM takes, let's say, 4,000 tokens, you can use that as your reference to break those your entire document into chunks of 4,000 tokens, so that you can use individual chunk. So this is the process of deciding the chunks, right? Now once you have these chunks, now you can take the entire chunk and build a prompt, where you will say that, given this type of data that you have, which is coming from IT systems, I want you to find out the top most common categories that this data will fit into, right? You can create that prompt and then send that to an LLM. Now this could be your private hosted open source LLM. It could be closed source LLM like GPT models. I've used GPT here for the test case, for the use case, but you could use any LLM that you want, right? So you take that chunk, prompt it to an LLM to get the categories. So you do that for every chunk. So every chunk will come back to you with a list of categories. Now, when it comes back, you will notice that there's a significant amount of overlap between the individual categories that all of these chunks are generating, and there might be some categories which are completely described with different kind of words, or maybe they're similar words, they are spelling differences in them, but they fundamentally mean the same thing, right? So you don't want all of that duplication to be there. So the next step is one more level 2 categorization, where you will take all these categories that your model, the LLM, has come back with for each individual chunk, and then club all of them together. Hopefully that will fit into your context size, because this is just a bunch of categories, probably not more than 100, or not more than 100 tokens even, right? I believe this will fit into it. fit your, fit into your context. If it doesn't, you could also think of doing one more chunk if you want, right? But the idea is you get you get the list of categories, and then you merge all of them together, and then you again prompt it to an LLM, where you will say that, given this bunch of categories that I've generated, try to merge the duplicate categories and then recategorize all of them into a final list. So what this process will do is this will create one final list of categories, where merging and deduplication, all of that has happened, and now you have something which is decently good enough for you to describe all the input documents that you have. Okay, so this is the first step, where you are using a map reduce approach, where you solve, breaking the large problem into smaller problems, and then aggregating the results across all of them to and understand the categories. Now once you have these categories, now the idea is to say, I know the categories. Now you can kind of loop through this document and say that for every category, try to find category from this list. If you don't find, you can add it to another's category and study the others category if you want to deep dive later, right? So let's go to the code, what we're doing. So we import the libraries that we need here, and then the log file, the log CSV, I read that. So we have the timestamp, we have the message. There are two columns. Now our idea is to generate the categories, which is to say group all of them together. So what we'll do is, let's understand what is the total token size of our data. So here what I'm doing is just removing special characters and merging all of them together, and then I'm getting roughly this many number of characters. Now one way to convert number of characters into number of tokens is to divide it by 4, which is a generally workable rule of thumb. But for the safer side, I've divided by 3 to understand how many tokens, what is the max size of tokens that I can expect from this entire data. So as I can see from my data, I have around 176k tokens, right? Now, the target model, the GPT 3.5 model that I'm going to use, may has, as I have checked, has around 8,000 token limit, right? Again, if I multiply it by 3, which is roughly 24,000 characters. Good. So I know that in one shot I can do 24,000 characters, but I have this many number of characters. So I will use this heuristic to chunk my data into probably 24,000. So I will just take the entire data and then take the first 24,000, make it a chunk, and then go to the next 24,000 biggies, and then just loop it through the entire process once, so that I have these chunks, and individual chunk I'm going to categorize them. Okay. So this is the chat model. I'm using Azure OpenAI, but you could use OpenAI also directly if you want to use. You need the endpoint and the key. And if you're using an LLM, which is privately hosted, an open source LLM, you just have to change it to the LLM model that you're using locally, right? That's it. So you have a connection to the model. And now what we have is, this is the chunking process of this is a process of chunking them and then generating categories. So let's understand what we're doing. I know the length of the entire data, the clean data. So I'll start from the first, and I have a token size which is modeled into 3. I've taken into 3. You could also take 4, but I'm for the safer side, I'm saying I'll take 3 tokens, one token equal to 3 characters, something like that, so that I don't face any max token limit error. I have a categories a list, Ellen, which is empty right now. So we just loop through it. We take a part of the chunk, and then we send it to the model. So I have this prompt which says, the top 10 categories into which the below text can be grouped. Just print the categories, do not add an example. So I just want the list of categories, right? And at the end, what I'm doing is, while I'm printing the answer, I'm also merging them. If you can see, I'm merging, appending them to the categories list. So what will happen is, at the end of the process, I have all the individual categories, and then I merge them, so that this final categories will be all the categories merged from across all the chunk, right? Coming down. So I have a print here, so you can see that every time it generates some, every chunk that it has done, it generates some 10 categories, and you could see them printed multiple times. So every time it might have a different categorization. uh, you might see that there is something which is similar, but they are worded in a different way. For example, if you have like AWS EC2 instance, but here it says only AWS EC2, right? Things like this, you can notice that there are, right? So I have all of that categories printed, right? So if I, so the categories, I've then merged them together into a list. So you can see this, this is the list. So this is the list of all the categories that were generated from the individual chunks, right? Now, as you can see, this will have duplicates, so we want to remove all of them. We also don't want this bullet numberings that have come. We don't want that, so we'll just use regex to deal with that. So let me go to the part where I've done that. Okay, so I'm just merging all of them together, because I want to now create a new prompt where I'm going to take all of this. So I'm just converting the categories into one single string, which is merged all of them together, a single string. And I'm going to send all of this to a new prompt, which is saying that below is a list of categories. Some are similar but slightly different wording. Generate the list of top 15 categories. Keep the categories short so that all of this can be grouped into. Just print the categories, not add anything. Okay. Simple, similar to the existing approach, the previous approach. We just group all of them into string and generate the answer. So as you can see, I have generated. I've set a temperature of 0, but you could also play around with this if you want to. Right? Now this is the final list of categories. So remember in my initial diagram I talked about that you get this final list of categories. This is exactly that, the final list of categories. Let's see that. Yeah. So this is the list of categories which is in the answer. Now I don't want this bullet number, so I have a simple regex which will just remove the numbers and I have the category list. So I have this list of categories which I believe is a good representation of the overall data that I am dealing with. Now, since I've decided this list of categories, I'm going to use this list to tag each message to a category. So what's the process? Simple. I have a prompt here where I'm saying that I have a function where I have this category list which is already defined. I'll send a text, like which is basically the row of the document. What I'm saying is from the given text that you have, you want to classify that into one of this text from this category. Do not generate a new category. Use the others category if it doesn't fit. Okay, this is the prompt. And I want a JSON, so I'm saying that I want it to express, come back with a JSON which has this key category, nothing else. It should not have an explanation, only a RFC 825 non-compliant JSON. This basically is to help me ensure that I get the data is actually a JSON. Now, in your case, you might find that it may not always give you a JSON, so you have to deal with that in some way, to some kind of text parsing. But in my case, I've not faced an issue. This prompt kind of worked in my case. So this is a function which takes the category list and the text and it tries to return back with the JSON which has the category list. So let's test that out. So what I'm saying is let's test this function by sending the first message in our data frame. So it says the category is virtual machine management, right? So it comes from the list that we had created. So one of the data in that list would be virtual machine management, right? So it's saying that this message can go into this category. Okay, fine. So this works. So let me add a category field to the data frame with the default NA value. And here what I'm doing is I'm just running a loop which will go through the entire data and try to find the category and add that category into the so every message it will loop through it, generate the category and append that category into the um, column, right? So if you see the header the head of the data frame, you can now see the first 5 rows have been tagged like this, right? So now you have a tagging for every message. Now you could use this in your production pipeline where you could take new messages coming in, automatically tag it to this list. You can also periodically at some interval, maybe like say 6 months or whatever interval is good enough for you to understand your underlying data might have changed, so that you can regenerate this list of categories and do this exercise again, uh, to to get newer categories based on your data, right? Just a small plot to see how does it look like. So most data is in the authentication and login attempts and like that, right? Now, so that's the approach, which is the map reduce chunk size chunking approach by which you have large corpus, and go about it. Hope this tutorial was useful for you. You got some ideas which you could incorporate in your work. If you like this content, please hit like and subscribe and follow the Git repo for new code. We're going to put up a series of tutorials which will help you speed up your adoption of LLMs. And thank you for being here.